Okay, folks, this is chapter 2-2. This is recording number 2. Okay, so the next one he talks about is the ogive. And this one is going to represent something a little bit different. This is going to be the cumulative frequencies for the classes. It's cumulative because it talks about, well, it's cumulative. Okay, so you got to know the definition of cumulative is. Let's take an example here. We're talking about the high temperature. Okay, it's if it's less than 99.5, how often did that happen? That's 0% of the time. If it's less than 104.5, that happened 2 times. Okay, less than 109.5, that happened 10 times. So it's hard for me to do it, but it's easy for you to do it. Look in your book. Okay, look in your book. So less than 109.5, what was the frequency? Well, it was this class right here. There's 8 times that occurred here, 2 times that occurred here. How about less than 114.5? How often does that happen? Well, here's 18 times, here's 8 times, so that's 26, plus 2, that's 28. So I predict that it's going to be 28, and boom, there it is. So less than 114.5 is 28. Okay, so you draw the axes and you label them, of course. You label them just like before, and then the y-axis is now the cumulative frequency. So taking it from current affairs, the cumulative frequency, you might see a graph that looks like this, and that represents how many people have tested positive for the COVID virus. Okay, it's cumulative. We don't throw out the people that tested positive a week ago. We accumulate them. Okay. All right. So that's what this is all about. Same as before. You have the x-axis is the temperature, the y-axis, the vertical axis, that's the cumulative frequency. Okay. All right. So it kind of walks you through it, and then you can also do it with an ogive. This is let's see here. Give me 1 second. Yeah, the ogive is a graph. Okay, so this is the ogive. Sorry. So you plot the points. Here's the points that you plot, and then you connect them with the line segments. And my comments before apply here as well. Between here and here on the x-axis, we don't have any information. So don't make that mistake of thinking that you can just go at this x point here, come up here to this y point, and then go across here and come up with something that has any meaning. You do not. There's no data for that. Okay. All right. So here's why his justification. Here's why he's saying that we need this. Okay. All right. Sounds good to me. Okay. So now relative frequency graphs. This is kind of a preview of what we're going to see later on when we talk about probability. A relative frequency graph is kind of like a probability, because the word relative makes it into kind of like a probability. It's using proportions instead of raw data as frequencies. What percentage do you have? Okay, so let's take a look here. This is the ages of state governors. Okay, we're gonna construct all this stuff. Okay, all right, we got all this. I know this is boring as dirt, but just trust me, it gets more interesting later on. You know, you've got all this. You know, walk your way through this. Do it at least once in your lifetime. Okay, and now we're going to draw the graphs for all this stuff. Okay, so here's the histogram. Here's the frequency polygon. Here's the ogive. Okay, wait a second. Where's the relative frequency? Okay, sorry, I kind of motored through that a little bit too quickly, didn't I? All right, so you come up with these frequency distributions, but this is going to be relative frequency. Okay, it's going to be the relative frequency of everything. So between 42.5 and 47.5, you have a frequency of 4. Well, relatively speaking, the class of 42.5 to 47.5, the relative frequency is 4 out of the 50. So 4/50ths of all of the data is in this particular class. How about pick another one, 57.5 to 62.5. You have 14 of these guys. So 14 out of the 50. So 14/50ths are in there. It's good that he picked 50 as the total, because now we can do the arithmetic very easily. 14 over 50 is the same as 28 over 100, so that's 28%. So that's why down here we've got 28%. Now, if it's not a simple one like that, well, that's why we invented calculators. You just plug it into your calculator. Okay, so now we have the class boundaries, we have the midpoints just like we did before, and now we have the relative frequency. And the reason this is important is many times you don't really care that much about the actual numbers. Many times what you're really interested in is the relative frequency, not the actual frequency. As an example, again, just using current events, maybe you are, instead of being so concerned about, the actual number of people in a certain age group that died, maybe you're interested in knowing what's the relative frequency. So if the, let's see here, what is this one we're talking about here? This is ages. Okay, let's use this. These are the ages, okay? Let's just pretend for a second that nobody under the age of 42 dies from the virus, okay? So maybe if you're only interested in, relatively speaking, what's the percentage of people that die in these various age groups. So between 42.5 and 47.5. Well, you don't care about the actual numbers. You want to know what the percentage is, okay? So you'd say here, well, it's 8%, 8%. For this group, it's 10%, okay? So that will be an example of why you're concerned about relative frequency rather than the actual frequency, okay? Now, the reason I said this is a preview of probability is because what we'll see later on is sometimes what we'll do is we will gather this data, we'll construct, maybe not use this exact same language, but we'll construct a relative frequency table like that, and we'll use that as our estimate for what the probabilities are for a particular event occurring, okay? All right, so this is all pretty straightforward. You plot the points. To get the frequency polygon, you draw these little line segments between the points. For the cumulative, you do the same thing. You plot the points, and then you draw the line segments, okay? All right, so now the next topic is talking about the distribution shapes. And the concept here is that once you draw the histogram, it's very handy many times to look at the shape and have some idea of what the shape looks like, okay? And the key point to this is that later on that we'll see that the shape of a distribution can also have a very big impact on what is the appropriate statistical method that you are going to use to analyze the data. And just to give you a hint, it's going to be primarily, is it more or less a bell-shaped curve? If it's more or less a bell-shaped curve like this, then we use a normal distribution, okay? All right, so these are the kind of the common shapes that we see. Bell-shaped, kind of looks like a bell, I guess. Uniform, it kind of looks like it's flat, okay? This is J-shaped, looks like it's J. This is a reverse J, looks like that, right? This is right skewed and left skewed. Those are, I can never remember which one is which, okay? I really cannot. I guess what I would say is that the right skewed means it goes downhill as you're going to the right. Okay, it's going downhill as you go to the right. And the left skewed, it goes downhill when you're going to the left. But I have a hard time remembering which one's which. Bimodal, that one's easy to remember because bi means two, modal means like the mode of something is what's the most common occurrence. Well, here we have two common occurrences. And then U-shape, boom, looks like that, okay? All right, so I'm going to let you look at those, read the information here, but you know, that's not very mathematical. That's just some definitions. Okay, so that's the end of section 2-2. In our next section, which we'll do in the next video, we're going to talk about the next topic, which is, just give you a preview here. Next topic is going to be some other types of graphs. There's a bazillion graphs out there, and the guys that do this sort of thing for a living, that's what they live for, is to create these graphs. It really is not very mathematical. It's not very analytical. It's just graphs. It's just different ways of showing the information. Okay, we'll get into that in the next video.